Hello, my name is Jacob Sindorf, and this is my final demonstration video for my embedded heart rate estimation device. Pulling up this first video is the actual verification system. So this system is going to be only on a breadboard, and it's meant solely to verify the heart rate of the subject. As you can see here, it's an Arduino Nano BLE33, the OLED screen, and the PPG sensor from that SparkFun pulse oximeter and heart rate sensor. You can see that it takes a few reads before it actually gets a 95 BPM with a 99 confidence. And it's not a very reliable reading source, even with as you can see, the subject's barely moving their finger on that and it's barely getting any readings. So if we wait here a little bit longer, you can see consistently got another 92. Now you can see that I instructed them to wiggle the finger just very, very slightly, and it already instructed a 0 BPM, no read. So it's an extremely motion artifact sensitive system, which would bring in the motivation for this device as well. However, this is a good way to verify with some confidence the actual heart rate of the subject. The next demonstration video is of the actual device. So prior to showing that, I have a few pictures here. We can see the circuit diagram of all the components. We have that SparkFun pulse heart rate oximeter, the Arduino Nano BLE Sense, and this OLED screen, as well as a 3.7 volt battery. Out to this here configuration and worn on the hand with the PPG sensor worn on the wrist. Playing this video, we can see that I had the sensor on their wrist, and this is when the program was turned on. Rewinding real quick, you can see the on switch clicked, then we're going to see the input from the screen. So it's going to go through that collecting data as a loop. So then it's going to collect data for 8 seconds, and it'll show 1 through 8 seconds on the screen. After the 8 seconds is up, it's going to go ahead and show all the pre-processing steps as a mark, and then the first of that and the final predicted heart rate. So now I instructed the subject to walk around during data collection, back and forth, just normal day-to-day walking. Now I'm just checking the device. We're only on the 3rd second of data collection. I instruct it for a little bit more of walking. And finally, we can check. It gave you that final predicted heart rate after walking. And now I'm going to have a comparison. Those heart rate values were relatively inaccurate. I'm just here showing that PPG sensor held against the wrist. It's a little loose and we need a better attachment point in the future. And now I'm instructing the subject here to use the SparkFun sensor to actually see their heart rate at the time. Again, it might take a few times to actually get the correct value. And you can see it's about 88, not 130. So some future work would need that pre-processing the PPG signal. The last demonstration of here is just solely the actual device. I'm showing just more of what this screen does. Here I'm just turning on the system. You can see this heart rate sensor down here. I'm just going to put my finger on it as a test. You go through collecting data. It's going to go through those 8 seconds. I'm going to fast forward through that. Now I'm going to go slow here. It's going to say start FFT, start stack, or start FFT, start Z-score, start stack. Those are the pre-processing steps that you would see in this presentation here, where it's going to collect for those 8 seconds, take the FFT, get the Z-score, and then stack to this final input tensor of 128 by 1. Playing this, you can see that right there. Then there's this final screen where it shows this test data. This test data is the first value of each of the stacks. So this is like value 0, value 32, so on and so forth of each of the stack, showing those magnets, those final highest Z-score values. And you can see it had an incorrect predicted heart rate, which would need some future work. I'm going to actually run the system again just to show how that works without my finger on it. So it's going to collect data. This is actually really important to show that the system actually will not get data results due to that. You can see it's going to predict it again. Here, I'm going to actually show just changing that accelerometer so not all those values are staying at 5. So again, I'm just going to wait for collecting data and begin to move around the accelerometer on that Arduino Nano, which is under the OLED screen. And now we can just wait until that stops. Again, start FFT, Z-source stack. And we get this not a number value, as well as 1, 2, and about 5, which is different from what it was previously. This not a number value is actually caused from the DC bias on that PPG sensor as I add this DC bias removal. So without having an actual finger to sense on there, it's going to end up returning not a number. However, with your finger there, you saw it was able to accurately read, well, not accurately, but it was able to read PPG data, and then using that and the model, it can get that final predicted heart rate.